All right, there are three similar right triangles. There's a small, medium, large. Small is the blue, medium is the green, large is the yellow. So, as we take a look at how the triangles are similar to each other, I'm going to take the large, you can work any way you want to. You can go from small to large, whatever. You just have to match things up. So, as I look at the large triangle, A to B is a long leg. The right angle is angle B, and B to C is the short leg. And all the rest have to have some sort of same order. So now we're going to go and look at different proportional parts of the three triangles. So I have AD, which at this point looks like it's a to AB, which of that triangle looks like a hypotenuse. So we're talking about the medium triangle, the greens. BC, which could either be the large triangle, the yellow, or the blue triangle. But since AD is a leg, BC must be a leg, which means whatever is left over has to be a hypotenuse. So I'm going to take a look between the two triangles here, and BC has to be a leg. So it's not going to be the blue, the small triangle, because that's a hypotenuse. So it has to be a leg. So I'm going to look at the large, which is a yellow. BC is a leg, and I have to match it to a hypotenuse. So therefore, it's going to be hypotenuse of the yellow. It does take a little bit of looking. It does take a little bit of matching up because you've got three triangles. So you have to kind of discover what's happening on the front end to figure out what's happening on the back end. Now, because we have these similarities, we have proportionalities. There's two types of proportionalities that happen within all three of these triangles. Geometric mean, which means there has to be some sort of twin. Now, we have to look at what we're given to figure out what the situation is. Now, I totally have some sort of altitude being given here. At just things that I've been given, you know, you make a drawing, things and givens, and then we do the labeling. I kind of did the drawing, some labeling, and then look at what I'm given. So I see I have a leg here. I have an altitude. And then that altitude goes back down to a leg. Altitude is the height of a triangle. So if that middle guy on the inside somehow is given by a number or an X, we have to look at the altitude situation. Small right triangle to a larger right triangle. Small side to large side, small side to large side. Okay, so that's going to be our setup here. So, I take a look at the smaller triangle, and generally you can kind of see which one's the smaller triangle. I'm just going to go with what I'm given. And when we do these altitude situations, notice that it kind of goes whoop, 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 whoop. Or if it's sitting in a different direction, it'll go base, oop, oop, over, that kind of thing, which looks very perpendicular in its whole aspect. So I'm going to go here, and I'm going to have small side 5, altitude 5. And then I'm going to go small side, altitude, to the large side, x. Notice we got the twins going on here. That's kind of the so we're going to have 25, because 5 times 5 is 25, equals 5x. Divide out the 5. It's kind of a nice, easy one. That's fine. But that's what happens with all of them. Okay, this is fun. I get to do this for a second time. Okay, this is a triangle that has actually no altitude going on. Notice everything's on the outside here, which is going to leave us to use the setup of hypotenuse, leg, hypotenuse, leg. So, since everything on the small triangle here, nice and easy. The hypotenuse is 5. Remember, it's always across from the right angle. And the leg attached to the right angle is 3. So now we have to look at the larger triangle. Well, that could be the medium triangle, but in this case, we notice we've got some good large triangle information going on. So what I'm going to do is pick the largest triangle, which has a hypotenuse and a leg. What you have to remember is that when you're given something on one side here, it's always being added. I have so much happening here, and it's going to be added to the next part happening here. So that's going to be x plus the 3. And then the leg is going to be attached to the big right angle here, and that's going to be 5. Okay, that's going to give us our little cross multiplying here. Notice we have the twins of 5 and 5, so all's good. 5 times 5 is 25, plus, I'm sorry, not plus, so I'm going to have to use my whiteout. That's me using whiteout. And, oh, let's go back here. Equals the 3 times the x plus 3. Cross multiplying. 3x plus the 9. We're going to minus 9 from both sides. That's going to give us 16 equals the 3x. Divide out the 3. And all great math students said, hey, x equals 8. Very good. Now, a few of you may have recognized that our smaller triangle here is one of those really cool Pythagorean triples, the 3, 4, 5, which means that in all honesty, you could have done a little bit. The first theorem, small side, large side, small side, large side, which meant side to the altitude, altitude to the side. It all works in the end.